The second point, liquid's pressure at any point inside the liquid depends upon the density and height of the liquid column above that point, right? So now the liquid pressure, that depends upon the density of the liquid. Either if I consider the water, it has different pressure exerted by it, or if I consider the oil, like any castor oil or any paraffin oil. So if I consider other than water, the oil product or oil materials, it has different densities from the water, isn't it? So again, this liquid pressure, that depends upon the density, and also this pressure is depends upon the height of the liquid column. Suppose here is the point, I can say somewhere here is the point. Here the pressure exerted by the liquid is different from when I take from this point, right? So at the point, I can name it as a and B here. So if I consider from point A to point B, at point A, the liquid pressure is less, right, than the point B, because if I take the height of the liquid column is different here, right? So according to this point, I can say that the liquid pressure can be depends upon the density and height of the liquid column. Clear? And next one, liquid exerts sideways pressure. See, in this diagram, I can say that, look at here. Here, the liquid, not only by the depth, right? Not only to the bottom, which also exerts the pressure to the sideways. Sideways in a sense here. In the side walls, here also, this liquid exerts pressure. And next point, an external pressure applied on a liquid in a closed container is transmitted uniformly throughout the liquid, isn't it? Now, if I apply the external force, right, from the external force, I'm going to apply the external force on the liquid. So at the time, in the closed container, suppose here it is closed here, right? Isn't it? It is a closed container now. Now, if I apply the pressure to the liquid, so whatever the pressure applied by the external source, so all the pressure will be equally distributed throughout the liquid. Okay, that is the last point. Is it clear? Right? Okay, then the next thing. Okay, here is, we have already discussed this point, isn't it? The third point we have discussed here, just now we have discussed. The pressure increases with depth, right? So as we can see here, if depth increases, right? If depth increases, the pressure exerted by the liquid is also greater, right? That's what I can say, that the deeper into a liquid we go or you go, the greater the weight of the liquid above and the higher pressure. See, if I name it the columns, I can say A point and B point and C point. If I see point A and point B and point C, see the point A which exerts lesser pressure, as a result, the water jet which falls here, somewhere at the distance from here to here, if I take the distance, which falls at this distance, then still the further the pressure is been exerted here, means because the greater is the depth, or when I compare to the A and B, the B has bit down, isn't it? It's been bit down. So now the depth, as the depth increases, the pressure is also increases. Now the distance is from here to here, right? If I say from here to here, then when it comes to the point C, even the depth is more, again it meant that the pressure exerted is also more. Okay, so this is what the meaning, that is nothing but if the pressure increases with the depth, if the depth is greater, then pressure is greater. Okay, right. Yes, and the next point is, the pressure depends on the density of the liquid. Yes, this point also we had come across in the previous point. Is in the previous slide we have discussed also. The pressure depends upon the density and height. So we have discussed the how, if the depth changes, then how the pressure is also changes. Now we can say, if the pressure depends upon the density of the liquid. See, if suppose the more dense is the liquid, the higher the pressure at any particular depth, right? If suppose here we have taken the oil, and we have taken the water, right? If I made the holes to the same level, say I have made the holes to the container to the same level, right? Same level. Now, if I see here, the oil exerts the pressure more here when compared to the water, because the more dense the liquid, the higher the pressure at in a particular depth, right? So this is the meaning of pressure depends on the density of the liquid. Okay, right. And, last point I can say, pressure does not depends upon the shape of the container. See, here we have the example. So now, so whatever the shape or widths of the objects, the pressure at any particular depth, that will be same. That will be remains same. That will remain same. See, as we can see the point A and point B and point C and point D. So it doesn't depends upon the shape. Say here we can see the something rectangular shape, and I mean the shape of the things, cylinder shape, something cone related shape, and here is some kind of cylinder shape. But it doesn't matter. So what shape it has, but at this particular point, the pressure exerted by the liquid is same. Okay. So now I can simply say that pressure does not depends upon the shape of the container. So we now you just have a look at into the video. Then if you get any doubt, we can clarify in the live session. Okay. Thank you, children.